A quick note on some terminology related to some different types of devices that you're going to see. So if we need a gate voltage applied to the gate in order to create the inversion layer, then we call that device an enhancement mode device. So enhancement mode device. And so we can also think about this as a normally off device. And so typically this is what we're going to focus on in this class, because the reason we call that normally off is of course because we said an inversion layer is sort of creating that path between our two electron reservoirs, we called it, and we'll figure out a little bit more about that in the next video when we look at our MOSFET structure. So the opposite case would be if an inversion layer is present even though we have zero gate voltage applied. And so this is going to be called a depletion mode device. And so again, typically we're going to be dealing with enhancement mode devices, but you will probably at some point come across a depletion mode device. And so we could also think of these as being normally on. So the other thing that I want to talk about in this video is sort of the analogous case of what happens if we have an N-type substrate. And just real briefly, let's look at our inversion case. So analogous case for N-type semiconductor as our substrate. And so again, let's just consider that third operating mode that we did before, which is our inversion. And so for our inversion, now instead of applying a positive voltage, we're going to be applying a sufficiently negative voltage. So we'll have something that looks like this. So this is negative, positive, this is some voltage. And what's going to happen is we're going to have negative charges on our metal. And because we have a majority electrons in our N-type region, they're going to be repelled away from the interface by the electric field that is induced across this oxide. So we have an electric field in this direction. And eventually we're going to create a depletion region. So we create this depletion region and we're going to leave behind fixed ionized dopant atoms. So we get something like this in our depletion region. And as that voltage, if it's sufficiently negative, we're actually going to be pulling up our minority carrier holes towards that interface. So those minority carrier holes are going to come up to the interface, and now we're going to have not an accumulation layer, we're going to have an inversion layer of holes in this case. So inversion layer of our minority carrier holes. And so again, as we see, all we had to do was just switch the polarity of this applied voltage when we had a different type of semiconductor. And so analogous to the electron reservoirs we talked about in the previous video, now we could think of, well, what if we had some hole reservoirs? So what if we had regions where we had a lot of extra holes? Well, creating that inversion layer of holes sort of creates this bridge between the two regions, and that's going to allow our device to turn on and allow for conduction of charges and ultimately current.